So hi everyone, my name is Martin. I'm British, I've come here from London, and I work for an organisation called the Bluetooth Special Interest Group. Probably most of you have never heard of the Bluetooth Special Interest Group, so let me tell you who we are. We're the organisation behind Bluetooth technology. Bluetooth is a standard, so all manufacturers that use Bluetooth, they work from the same technical specification, and we produce that specification. We don't make products, we don't make software, it's all about the theory, and thousands of pages of engineering specification, that's what we do. Now, Bluetooth has been a phenomenally successful technology. Some technologies never quite arrive, we hear all the hype and they never quite even materialize. Some technologies come and they go quickly, but Bluetooth has been with us now for over 20 years. It actually says it here on my t-shirt, so it must be true, okay? But if we go back to the very early days of Bluetooth, the year 2000 was probably the first year where there were actual products you could buy, and in that year, a total of 800,000 Bluetooth devices shipped. These days, thanks to the success of Bluetooth, there are now 10 million devices shipped every single day, which is an enormous number of devices. It's 4 billion a year, and this number is growing all the time. We have graphs back at the office, and it's still kind of going up, which is really cool. I think there are a number of reasons why Bluetooth has been so successful, and one of them is meticulous attention to detail in creating an engineering-led standard so that devices are interoperable. In other words, it works really well because of that. But also, it's been adopted by pretty much every developer platform that there is. So there are APIs on every device pretty much that you can think of. Certainly on your smartphones, whether you're an Android fan or an iOS fan, there are APIs for Bluetooth there. But that's not the only place we'll find them. When I talk to people about Bluetooth, I think the first thing that they tend to think of are consumer electronics, because that's been their experience of using Bluetooth, using it with their smartphone, with that heart rate monitor they have when they go running, things like that. But in actual fact, Bluetooth has been broadening its capabilities and finding its way into the world of the enterprise computing as well. Various things have brought this about. About 3 years ago, the range was increased, for example. It's now over 1 kilometer. In actual fact, I was at a conference in January, and I saw a company presenting, and they'd achieved a range of 3 kilometers with Bluetooth Low Energy, which is more than I expected. I knew it was more than 1 kilometer. So it's a totally different technology in some ways to the Bluetooth we had 20 years ago, where the range was maybe 10 meters. We also have a mesh networking capability as well now. Rather than just having two devices talking to each other, you can create networks of tens of thousands of smart devices, and I'll tell you more about that later on. So Bluetooth is very different to the way it used to be, and consequently, it's a good choice for all sorts of use cases that previously it was not. Now, in the world of the enterprise, there's a certain approach to systems design that, as web developers, you'll be very familiar with. No longer are we developing native applications for the various different types of platform that exist in the company, the different versions of Windows and the few Macs in the marketing department, the Linux machines in the IT department and stuff like this. No, the browser is the platform. And it's about cloud computing and web services and things like that. You know all this. This is one of the primary benefits of web technologies. And the Internet of Things. The Internet of Things is something I guess we've been hearing about for a long time now, but it's not hype, it's reality. You know, I talk to companies that are deploying real IoT applications all the time. IoT is absolutely here. This is the age of the IoT. And if you look at the applications, the things people are doing under the heading of Internet of Things, they're nearly all enterprise applications. So if that's the case, then I would suggest that given the approach that enterprise systems developers like to take to the world of enterprise systems, and the fact that Bluetooth is one of the technologies seen as a key enabler of the Internet of Things, it's probably quite important that browsers know how to work with Bluetooth because we want the browser as the platform for those enterprise systems, and Bluetooth is one of those key communications technologies for IoT applications. And happily, that's my proof, by the way, we have this thing called Web Bluetooth. So who here has actually worked with Web Bluetooth? Anybody? Small number of you, very good. How many of you had heard of Bluetooth, Web Bluetooth before you came to this session? Very good, okay. So here's the status of this thing. It's not a W3C standard. I really would like it to see it become a W3C standard, but today it's not. It's pretty much a Chrome-only play. So Google have done an amazing job. Google are really into this. You'll find Web Bluetooth supported in Chrome, on Android, on Macs, on Chromebooks, on Windows 10, and on Linux machines, maybe with a little bit of tweaking. Samsung have their own browser, the Samsung Internet Browser, but guess what? It's really Chrome underneath the hood, and therefore it supports Web Bluetooth as well. You may have seen what was either a press release or a leak, I'm not sure which yet, last year, that revealed that Microsoft were leaving Edge behind, Edge as we know it, and moving to another browser, perhaps called Edge still, I don't know, but which will be based on Chrome. So Edge will, or whatever it's called, the Microsoft browser will inherit all those capabilities that Chromium has, including Web Bluetooth. So the future looks quite good for Web Bluetooth. It's not a standard yet, but I think it'll get there. So let's talk about the Internet of Things. There are thousands of case studies out there to go and read about, but I think they distill into two main areas, two primary use cases. We're either monitoring systems, typically this involves sensors, we're monitoring devices, environments, machines, their current state and so on, and there's data being transmitted by sensors somewhere in that mix. Or it's about controlling machines. It's about machine-to-machine control, controlling individual devices, whole systems, whole environments. And actually, often these two things are used together. You'll find sensors providing monitoring data, providing a kind of feedback loop that gives rise to control decisions. Those are the things we see in the IoT. Now, what can we do with Web Bluetooth? Can we create monitoring and control applications with Web Bluetooth? Well, it so happens that you can, and it so happens that being brave like I am, I'm going to try and show you some things right now, live before your very eyes. So, let me just get set up here. There we go. The first thing I'm going to do is this. I'm going to log into a web system that I developed and which is used in British schools. You look like lovely people, but just in case, I'm going to hide my credentials as I log in, okay? There's a hacker out there somewhere, one of you at least, I just know. So, I'm going to try and log in blind. Which might have worked, and it did. Let's bring that back up. So, I've got this application. It's used by educators to teach science, technology, engineering, mathematics, that kind of thing. And amongst the various applications, I have a data logger. Now, in my hand, I have a microcontroller. It's a small computer, it's got memory and a processor, and it's running code that I wrote. It's also got Bluetooth, and it has some sensors inside it, including an accelerometer. Now, watch carefully the sequence of events now. I'll explain all of this later on. The first thing that my web application has to do is it has to discover this thing so that it can then connect to it and interact with it. This thing is currently doing something we call advertising. This is a Bluetooth capability some devices have. Advertising means broadcasting small packets of data every 100 milliseconds or something like that. Those packets of data have information in them that my web application can use to identify this type of device. If I click scan, up pops a window. Listed in that window is the one and only device that it discovered that seems to be the right kind of device. So now as a user, I'm selecting it and I'm going to indicate I want to collect. You may see a letter scrolled across here when I do. I didn't see that, but I hope it's there. Did that work? Now I'm getting nervous. Let's try that again. God, I hate demos. Hands up who hates demos. Okay, so it's there again. Just pretend that didn't happen. Okay, the C went across, it connected. Common web application. Thank you very much. These things do this stuff just to scare you. That's what happens. Now, I have my demo configured to plot accelerometer data. If I click Start now, that sends a Bluetooth message, a special message to my microcontroller wirelessly to say, I'd like to have accelerometer data, please. And now it's streaming to my laptop and into the web application. 3 values being plotted, X, Y, and Z, for 3-dimensional acceleration. X, Y, Z, okay? Very boring right now. If I pick the thing up, though, we get some action, some things happening. This is live data being acquired from sensors wirelessly to a web application, which is not something we were able to do earlier on. I was in the very first session in the audience earlier today, and we saw a picture of the first web page. Text, links, nothing else. The web has come a long way, okay? So that's monitoring. That's definitely the first thing we can do with web Bluetooth. What else can we do? I'm so glad you asked. Because down here, somewhat damaged from being in my suitcase, I have this thing. I made this, can you tell? It's a kind of vehicle. It's got another microcontroller in it, okay, for Bluetooth, but it's also electrically connected to motors to drive the wheels. And it's got a flag that I made. So I'm going to put this here, and again, the chances of this working, well, who knows? Let's see. Let's go into a different web application. Same sequence of events. We scan. It's immediately discovered my device. I'm connecting to it, which is looking promising. And I have this weird blob on the screen. This is actually a trackball, because if I move it, oh, look, it drives across the stage really slowly, which I can tell you are just amazed by. And I can spin around. I can actually go backwards as well, which is very thrilling. Are you excited by this? Well, it's good that you're very easily pleased. I'm very pleased about that. But seriously, what I hope I demonstrated there, having brought this all the way from London, is the fact that web Bluetooth might not be quite there yet in terms of standardization, but it's a very capable technology. And those primary use cases that we find in the Internet of Things are very much possible. So, moving on. I mentioned right at the beginning that Bluetooth itself has changed. So it's evolved so that it's almost unrecognizable from the technology we had 20 years ago. And one of the more recent advances is mesh networking. It's really interesting. You can create networks of tens of thousands of devices. What you just saw was 2 devices talking, point-to-point connection, communication directly between them. Mesh networking is an entirely different proposition. In the first instance, this was conceived of for creating smart buildings. Every light is a node in your network, every air conditioning unit, every heating unit, every system that governs the behavior of the control and monitoring of the environment in the building becomes part of a Bluetooth network. It's a very impressive, very interesting technology. For you guys as web developers, here's what you need to know. Most of the scenarios in things like smart buildings and smart industries are about machine-to-machine communication. Sensors are informing the lights whether they should be brighter or dimmer, for example. It's all automated. But people need to interact with those systems too. Okay? We need user interfaces for monitoring and control of all the things in that smart building. So, the Bluetooth mesh standard includes a special type of node or device in your network called a proxy. The proxy is a type of device that looks a bit like a normal Bluetooth device. You can form a one-to-one connection to it. And then if you do it right, if you know how, you can inject special Bluetooth mesh messages into the mesh network via the proxy node that you are connected to. So, I decided to try this. I created my own demo. It looks like this. I'm not a web developer. I apologize for the horrible color scheme, but this is the best I could do. More importantly, I built this thing. So this is 4 Lego boards kind of stapled together. There are 64 microcontrollers mounted on it, all individual microcontrollers just like this one. I don't have a live demo to show you, but I do have a video I can show you, which is probably this one. So just check this out. I don't know what it means. Hang on. Right, so there's my UI. This is quite brief. There's my network of 64 devices. They're all capable of being switched on or off or having their level changed in some way. You'll see how I do that. That device next to my laptop I'm using as a proxy. It has more memory than those small devices. Proxies need more memory. And there's my web page. Now, first thing I do is what you've seen already, is I scan, because I'm looking for the proxy node to connect to. I've now connected to it. Bluetooth Mesh uses an addressing scheme where devices subscribe to what we call group addresses. Subscribe means they're listening for messages sent to that address. And by clicking around my UI, I can change the destination address. Each device in my grid has subscribed to 3 addresses. 1 for the panel that it's in. There are 4 panels. 1 for the column it's in and 1 for the row that it's in. There I've sent an on-off message with a value of 1, which means please switch on. And I've sent it to the group address that means all devices in the network. And if I click that button, I send the same message type with a value of 0, and they all go off. So I'm controlling everything in a potentially very large network indeed from a web browser. This is a whole new category of web application waiting to be written to accompany all the new technology that's going into smart buildings and later on smart industry, maybe smart agriculture and so on. And here I'm playing with levels, I'm changing the level. It's not just for lights, I'm just using lights as an example because they're easy to relate to. So there you go. Web Bluetooth can be used for all sorts of tremendous things. By the way, I always get asked what it looks like behind. That's what that demo thing looks like behind. It's a miracle it works. So let me tell you a little bit about the theory of Bluetooth and, well, Bluetooth Low Energy itself first of all, and then we'll look at Web Bluetooth. So devices like this one we call peripherals. That's actually a term you'll find in the specification. Inside them, they have a table of data. Each data item reflects some state or capability of the device. Those data items are called characteristics. That's the formal term that you'll find in the spec. And they get grouped together into things we call services. So there's like a hierarchical structure here. Characteristics, the data items, can have special things called descriptors attached to them. And they let us control certain aspects of the way that characteristic behaves. Now, you already saw this, but let's recap. There's going to be a typical application flow. If you write any Web Bluetooth application, it's going to have these ingredients. You will need to implement device discovery. Your peripheral device will be advertising, as I explained, small packets of data. Your web application has to scan for those packets and filter out ones that are clearly not relevant. You're trying to present the user with devices that are appropriate for this application. Once the user has selected from that dialog that pops up, your code is going to connect to that device. Now, you cannot scan for and connect to Bluetooth devices behind the scenes without the user knowing. That would be a big security issue, I'm sure you'd agree. So consequently, that dialog that pops up, that's under control of the browser, and the user must interact, must make a conscious selection before connecting to that device is permitted. That's how the security works. Once you've connected, you do something called service discovery. This is asking the device you've just connected to, what does your attribute table look like? What services do you have? What characteristics? And maybe we want to just be very sure it's the right type of device. If we don't find what we expect, we're going to disconnect. And once we've done that, now we can start to interact with the device, which generally involves reading and writing values from that attribute table. In fact, to be precise, we can do things like read values. So I'm reading from some medical device here. And by the way, wouldn't it be amazing if a country was to try and launch a national health monitoring service where Bluetooth medical devices were part of the kind of acquisition of data that indicates the health or otherwise of patients? How else would you do it other than via the web? It's the only way practically that you could do something like that. You can, of course, write to characteristics subject to their permissions and change values. And then there are things called notifications. Notifications are enabled by you telling the device, please send me values of this characteristic whenever they change, or maybe on a timer. And that's what I was using with my data logging example with the accelerometer. Those were notifications coming in from this device. So these are the kind of operations you're going to work with: read, write, and notify. So there's my values streaming in. What does the code look like? Let's find out. Start here. Hope you guys can read this. All I'm doing here is defining an object that contains some parameters, which I'm going to use in a call to a Web Bluetooth API function in a moment. Those parameters are going to be used for filtering purposes. I don't want every single Bluetooth device to be listed, because there could be hundreds or thousands. In this room, there are probably hundreds right now. Here's my first example Web Bluetooth call, navigator.bluetooth.requestDevice, with my options object as a parameter. Call that function. It will only work, by the way, if your page has been loaded over HTTPS. That's another security feature. It will start the scanning process, and any device that meets the criteria specified in the options object will be presented to the user in that dialog that you saw. Okay, so that's how I kick that off. We're using the promises pattern. When the user selects a device and says, click that one, my then clause executes. If they abandon, it's the catch clause that executes. When the then clause is executed, I'm passed a parameter I've called device, and that's an object that has information about the selected device in it, okay? When I have a device that's been selected by the user, I'm going to connect to it. And here I'm calling another Web Bluetooth function, which is gat.connect, and I'm calling that on the device object I was just given. Once I've connected, I'm going to do things like add an event listener, which will get fired if the device disconnects. Maybe the user walks away and walks out of range, several kilometers maybe, but the connection drops. I want to know if that happens. I want my user interface to change. So I've got an event listener that will inform me of that taking place. But once I've connected satisfactorily, I'm going to do the service discovery step, where I'm going to try and find out more about the remote device, find out what its attribute table looks like, what services it has, what characteristics it has. Here I'm calling get primary services. That's the API call for Web Bluetooth. And it returns a list, actually an array of service objects, which I then iterate through. And for each service, I call another Web Bluetooth API function, get characteristics. So I'm now dropping down a layer in the hierarchy, and I'm going to find out all of the characteristics attached to that service. So I have a kind of nested iteration going on that lets me explore everything that's in that attribute table until I know everything I need to know about that device. Notifications. In the example of my accelerometer data, I needed to tell the remote device, please start sending me accelerometer data as notifications periodically. And I did that with this API function, start notifications. I'm hoping you're thinking, oh, this looks easy, because it really is. You need some background theory to understand what these API functions are doing. But using the API itself is a real piece of cake. Who likes cake? See? There you go. Everybody likes cake. And in actual fact, having asked the organizers if I could have some extra time, I'm probably going to finish a little early, it looks like. But what do you do next? If you're interested in knowing more about this stuff, we have all sorts of developer resources at our website. Our website, just in case you haven't guessed, is bluetooth.com. Can you remember that? I think you can, I can tell. And at bluetooth.com, if you click on resources, you'll find we have things called study guides. They're all educational resources for various different aspects of Bluetooth, including web Bluetooth, and they all have hands-on parts to them. It's not just reading. You read stuff, you write some code, you read stuff, you write some more code, you make things, okay? There's loads of fun things to do there as well. That's probably all I need to say there. I'm on Twitter, if you're into that kind of thing, which I'm not sure I am anymore, but there you go. Do you have any questions for me? Thank you for listening, by the way.
Thank you.
Okay.
Well, first of all, thank you for your speech and for a British accent.
Oh.
You guys really move things forward, and I have incredible respect for everybody who's behind with standardization stuff. Keep doing this. And the question is about web Bluetooth, but the situation is absolutely the same if we're talking about web USB. We had a case when we tried to connect a device to PWA, Progressive Web App, and we were constantly running into the same issue. Basically, you have a device which should work fine on paper, but in fact, sometimes you just unable to discover it from the web Bluetooth API, or sometimes it just throws absolutely, errors which are hard to track down and all that stuff. So my question is, maybe you can give us a few examples of production apps, web apps that use web Bluetooth, okay. And that's it.
Okay, so it sounds like your question is you're looking for examples of production web Bluetooth applications, but your lead-in was about some problems that you've had.
We work with this before you try, and
okay.
It's a huge, huge issue for me, okay. And it's the same with web USB.
Okay, I'm now going to exaggerate my British accent because apparently he liked it. So, first of all, I don't know of any production web Bluetooth applications at all. It doesn't mean they don't exist, but I can't think of any examples right now. It's not yet a standard, so that I think will limit its adoption. Any sensible web developer is going to be careful about selecting something which is not cross-browser, I think. Am I right? Yeah. Yeah, I mean, it's your choice. I think it's got lots of potential use today, but I'm more interested in this as something which I hope will become a standard and we'll see equally supported across all browsers. Then it becomes a really important thing. As for problems that you had, I'll be honest with you, I've had no problems like that at all with web Bluetooth. I've played with it quite a lot now. One thing to always remember, these things, they're not just electronics. They do contain code, right? Almost everything that they do. Almost everything that they do is a consequence of the code that's on them. Who here has written a driver, ever? Anybody written a driver? A device driver of any sort? A couple of people. Then you know how unbelievably dumb electronic devices are, correct? I mean no disrespect to the electronics devices of the world, but it's all about code. So if you've had problems with a device, I mean, maybe there were some issues with that device. It does happen. From our point of view, we have testing procedures that all Bluetooth certified devices have to go through. And they're quite good. They're almost certainly not perfect, though, okay? Because this is a continuous improvement situation, something we're working out all the time. But with 10 million devices a day, they're probably okay. My guess is you probably had a device with some issues. The other thing, though, that can confuse people is pairing. So who here has heard of pairing with Bluetooth? I just like making people put their hands up. It's just, I'm like a control freak. I can make you raise your hands. It's good fun. So pairing can cause confusion because when two devices pair, they form a secure relationship. Those are just words. Technically what happens is there's an exchange of data that results in a number of shared security keys being created. Those security keys are used for various purposes, including but not limited to encryption. Now, if your web Bluetooth, your web browser thinks the laptop is paired to this device, but you've just installed some new software on it, some new firmware, and you've wiped out the pairing keys, it isn't paired anymore. It thinks it's paired, but it's not paired, so it starts to try and establish an encrypted link, and it can't, and it fails. So now you're at the mercy of error messages, and we all know about error messages. Informative ones will help you, but then there are all the other error messages. So, things can go wrong. There's some skills, some knowledge you need to be an effective developer that uses web Bluetooth or Bluetooth from any platform. But generally, I have to say it works pretty well for me anyway. Long answer. Very British accent, hope that was okay. Another question. Oh, yeah. And by the way, Mr. Moderator, could you please reward my new friend for his excellent question? You got it? Okay, that was a good question, thank you. Who's next?
So, thanks you for raising up this question. And I do have a topic. Let me start my question with smart houses example. You have multiple devices registered to Wi-Fi network, which makes them accessible from anywhere worldwide where you have internet access, right? And let's assume you have low energy Bluetooth device. And what's the problem with using just proxy Bluetooth device to register these low energy devices to the Wi-Fi network, which also makes them accessible worldwide? But instead, what advantages of using this web Bluetooth technology? Okay,
I think there were 3, 4, maybe 5 questions in that question. I'm going to try and separate them. So there was, what's the advantage of using web Bluetooth, I heard. There was something about coexistence of Bluetooth and Wi-Fi. So I'm just going to talk about those topics, and hopefully I'll hit the questions that you asked. So, Wi-Fi and Bluetooth. Specifically here, we're talking about a flavor of Bluetooth called Bluetooth Low Energy. Some people call it BLE. I'm not allowed to, but you've probably read BLE on the web, I'm sure. So Bluetooth Low Energy is, as the question kind of acknowledged, a low energy communications protocol. That means it uses very little power. It means that you can run devices like this one have tiny coin-sized batteries for literally years. That one's been in there for years. I have devices at home that have what I'm assured are the world's smallest solar panels, and that powers the device even inside with ambient lights. And that's possible because the communications protocol, the stack used, Bluetooth Low Energy, requires so little power. Completely different to Wi-Fi. So Wi-Fi is high bandwidth, video streaming, Facebook updates if you're into that kind of thing. Okay, that's what it's really good, that's what it's for. IP, a kind of hub-spoke topology with a router in the middle. Bluetooth is not for those things. So they coexist in terms of meeting requirements very happily. They're complementary. If you need, for example, as you will when building a smart home or smart building, you will need sensors. Sensors are absolutely key to all the automation scenarios you find in smart buildings and smart home. Where are those sensors going to be? They're going to be in the walls, in the ceiling, under the ground, in the soil in your garden, under your driveway, in your gate posts. They have to be really power efficient. You cannot be wiring them to the mains or changing the batteries every week. It makes the whole idea an impossibility. So you need low power wireless communications for these scenarios, and you're going to need 2 wireless communications in total. You will need Wi-Fi for some requirements, and you will use Bluetooth Low Energy for others. So that's a view with respect to sort of functionality, use cases, and capabilities. The other question that I get asked about regarding Wi-Fi and Bluetooth is, do they interfere with each other? Don't they all use 2.4 gigahertz? I get asked. And yes, that's true. They both use the 2.4 gigahertz frequency range, but it is a range. It starts at 2.4 and it goes up to a certain upper limit. Bluetooth uses something called adaptive frequency hopping. Actually, let's do Wi-Fi first. Wi-Fi lets you choose a channel. You know this from your router at home, right? You can choose a particular channel that Wi-Fi is going to use. But once you've chosen that channel, that's it. It will communicate on that channel. Maybe you've investigated what your neighbors are using. because your Wi-Fi wasn't working well and you've chosen a different channel to avoid interference with next door's Wi-Fi and so on. Bluetooth is way smarter than that. It uses adaptive frequency hopping. Once you connect, the available 2.4 gigahertz spectrum is divided into 37 radio channels, and automatically the two devices communicate, hopping between channels every few hundred microseconds. It's extremely robust in busy radio environments as a consequence to that. And the adaptive part of the name, adaptive frequency hopping, is because if a device discovers that one of the channels is not working very well, we're getting lots of errors, stop using it. It adapts to the environment to get the most optimal communication sort of reliability that it can. So what is the advantage of web Bluetooth? The advantage is that it's the web. It's like saying, what is the advantage of the web as an application platform? Okay, it's platform agnostic, use it anywhere, all those things that apply to the web and that make you a web browser, a web developer and come here, they apply here. But you get to do some of these device control and monitoring scenarios using web technology rather than having to write native code for the Android devices that your workforce has, for the iOS devices that they have, for the Windows 8 machines that they still have out there, and the Macs that they have, right? It collapses that problem. So that's the advantage of using web Bluetooth as opposed to native apps. Hope that answers your question. There's a free gift heading your way, I think, if you don't have it already. Thank you very much.
You partially answered my question. So question was, you can use web Bluetooth technology, but I understand you can connect only devices which are around you, right?
No, not really. Yes and no. So if we're talking about point-to-point connections directly to devices, they have to be in range. That's true. But in the context of something like a smart home or smart building, you will deploy a Bluetooth mesh network. Devices do not have to be in range. This was not our Bluetooth mesh presentation, so we just touched upon that. Your mesh network can span very large areas. We've got hundreds of meters range between devices for direct communication, but you're sending messages and they hop across the network from device to device to device at the speed of sound. So my mesh network could embrace, if that's the right word, envelop, thank you, a whole building, a collection of buildings, even a neighborhood. And my web Bluetooth application only has to be in range of one device acting as a proxy. So maybe you have one device in each room as a proxy, but then I can communicate with any device elsewhere in the building.
Okay, that answers my questions. Thanks.
Thanks.
Yeah. Hello. Yeah, thank you very much. Well, I will try to ask two questions, but yeah, the first one is if sending some complex data like audio or video files, what the strategy of sampling it and how to work with it? Can you?
Okay, so to clarify then, we now have three Bluetooth technologies. Bluetooth Low Energy, which is what web Bluetooth works with. That's the newer type of Bluetooth, it's 10 years old. Bluetooth Mesh, which is for big networks, tens of thousands of devices, which I just talked about. And the old Bluetooth, Bluetooth BR EDR, Basic Rate Enhanced Data Rate. That's the old Bluetooth. It's still very, very big in the world of audio. Okay? That's what tends to be used for things like Bluetooth headphones. It's the old BR EDR. You can't use that with web Bluetooth in the way that I've been describing. So this is just about the Bluetooth Low Energy devices. And I actually know a fraction of what I know about Bluetooth Low Energy and Bluetooth Mesh about the old Bluetooth BR EDR, so I can't help you too much on audio codecs and things like that, I'm afraid. However, I'm going to tell you one thing. If you're interested in audio, for many, many years, Bluetooth audio has been about two devices, one streaming audio encoded audio data over a Bluetooth BR EDR connection to something like headphones or a headset in a car. That's going to change in the relatively near future. Next generation Bluetooth audio is coming. I can't tell you more than that, but keep an eye on Bluetooth.com. It's going to be pretty interesting.
Okay, and thank you. And the one more is, can we understand how far is the device is?
Can you determine the distance?
Yes.
Okay, my favorite answer to all questions is yes and no. Okay, so here's the truth. Okay, 2 parts to my answer.
One more questions, please.
In the simple case, a device can use signal strength, it's called the RSSI, Received Signal Strength Indicator, to estimate how far away another device is. But it's not very accurate. A lot of people do it with some success. Who's heard of Bluetooth beacons? Hands up again. Okay, so beacons, small devices, they transmit a unique ID, they get installed all over airports and shopping malls and things like this. And as you're walking along with an app on your phone, it receives a transmission from a particular beacon with a particular unique ID, so the application knows where you are. Now, if you want to trigger some response when you're sufficiently close to that beacon, you have to estimate distance. And there are 2 ways of doing that. One is just by taking the signal strength from the transmitted packet that you're receiving, and there's something called a path loss calculation that lets you calculate a distance, but it will not be very accurate because it's very dependent on the environment. People are full of water. Water affects radio communication. It's good enough for many, many use cases, but it's not good enough for some. The smarter, more sophisticated beacon solutions, they use kind of triangulation. I've got a signal coming in from a beacon I know is over there, one from over here, and they try and improve that estimation. So the yes and no means really it depends how accurate you want to be. However, the very latest version of the Bluetooth specification, version 5.1, was released at the beginning of this year. The number 1 feature that it released was the ability to do very, very high accuracy direction finding. So with this new 5.1 capability, if there's a device over there that's transmitting a specially encoded signal, my device can figure out to within very, very high degree of accuracy which direction that's coming from. And devices like the one over there have multiple antennae. They have an antenna array. And so what I can do is I can determine the angle that the signal is coming from relative to a horizontal plane. And I can also determine the angle the signal is coming from relative to a vertical plane. And where those 2 lines cross, that's where I am. We're talking 10 centimeter accuracy. It's possible. Environmental issues, blah, 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 we can change the accuracy, but that's next generation location services from Bluetooth, direction finding. Thank you. I have another question. Is it possible to...
Yeah, one more.
Okay, you might have to shout. Oh, yeah. It's over there, sorry.
Yeah, that's me. First of all, thanks a lot for the live demonstration. It was quite impressive. And my question will be about the mesh network scenario. Well, how reliable the mesh network would be against the denial of service attacks?
Oh, that's a really hard question, actually. Well done for asking a really hard question. It's hard because I'm an engineer and I like to give engineering answers with some kind of proper basis to them. I can talk to you about reliability in general. There are a number of reliability in wireless mesh networking is really hard. It's a very tough engineering problem. There's an RFC called IP Group Multicast. You might want to Google for that and have a little read. Within 2 pages, you'll be like, this is impossible. Pretty much they spend most of their time in that RFC telling you about all the difficulties, all the problems. Bluetooth Mesh was designed with the hard scenarios, very large networks in mind from the start, so we could tackle those big problems. Other low-power wireless mesh networking technologies probably weren't. They're about thermostats, small networks. So in general terms, ignoring denial of service for the moment, there are a number of strategies built into the technology that are all about creating high levels of reliability. For example, if I transmit a message that means all of the lights on floor 1 switch on now, that message, without me needing to do anything special, will travel via multiple paths through the network. So if one path is broken, a copy of that same message will arrive by a different path. So this is architectural redundancy. So there are things like that. Denial of service, though, I think is impossible for any wireless technology to 100% reliably defend against. I could, for example, decide to take a truckload of microwave ovens into the building of my enemy, let's say, switch them all on and run away. they also use 2.4 gigahertz, and probably it's going to disrupt Bluetooth and Wi-Fi and anything else, your cordless phones. So that kind of denial of service attacks on wireless networks that operate at that kind of radio level, the physical layer, probably quite hard to defend against for anybody, I would say. Other than frequency hopping. Frequency hopping actually is your only choice, so maybe we're better there because we hop all over the place, we don't just stay in on one channel. That's about the best I think we could probably do there, and probably as good or better than anyone else.